Hey guys, in today's video we're going to be talking about something that's called confidence intervals, and it relies on what you did last chapter in chapter 5, and that's why we re-quizzed on chapter 5, because it's important that you understood how to use the chart and understood the areas underneath that bell-shaped curve. These confidence intervals are they tell how confident we can be that a certain piece of data falls within a certain region. And we'll start with numbers 36. I'm going to dig right into it, and I'm going to show you the procedure to it, and I'm going to show you the things that you need to know. And you need to know these things here. So you pick them right out of the problem when you start. Now this problem talks about stock prices, I believe of an Apple stock. And it says that they took a random sample of 36 days from the month of February 24th, 2016 to February 24th of 2017. So they took this random, just grabbed 36 days, and they wanted to see what was happening to the Apple stock. And they told us that the average they found was the Apple stock was going for $116.16. So I'm pulling information out of the problem. And they told me the standard deviation was $10.27. And remember, one standard deviation on either side of this $116 would say that about 68% of all the stock days would have that price between those two. If we went out two tens on either side of 116, then we say about 95% of the days fell within those two intervals. Well, this one we're going to find something similar to this. We also want to look at, well, first of all, n is 36, and we want to find out, well, what is the margin of error? And a lot of times you'll hear this on the news during election time and other things, that the margin of error was such and such. On the bottom it'll say it. It'll say 64% voted for this candidate, and on the bottom it'll say plus or minus 2% or plus or minus 2.5 or 3%. We also need a z-score. So this one we want to be 90% confident, and we want to know what interval of price amounts can we be 90% confident. So we're interested in this middle 90%. If that middle 90% takes up this part of the area under the curve, then there's 10% left over for the two sides. And we split that up to 5 and 5. Now if we look in our chart, and I'll show you an easy way to do this in a minute, but I want you to get the idea. If we look in our chart, and I look for the z-score that's related to this top 5%, and then I would look up 95%, because this here would represent 95%. Even though our confidence interval is 90%, we would look up 95, because our chart always gives us areas to the left of the score that we're interested in. So if that 10% is split up into two parts, 5 and 5, we would look up this 95%. So if I'm going down this chart and I'm looking for 95%, and it should land actually right in between these two scores. I don't know if you can see that or not. These two scores are a 1.6, and we're coming over, hold on, 1.6, and it's in between 4 and 5, and it's directly in between 4 and 5. So we're going to say 1.645. 1.645. That's going to be our z-score. It has a little cheat sheet down here, is that when we're talking about, these are called critical values, when we're talking about 80% confidence, 90, 95, or 99, which most of the problems are, they will have these as what they call critical values. These are the z-scores that always pop up, and this one, the 1.645, always relates to the 90%. So they kind of pulled these out of the chart for you because they're used so often, those 4 scores. So we have everything we need, and we're interested now in our margin of error. If we want to find our margin of error, we would put a margin of error here and put our 1.645 times our standard deviation, divide it by the square root of n, which comes out nice because in this case they made it a 36, so it would come out to be a 6. And if you took your calculator and you found that margin of error, you would have gotten, I did this somewhere and I can't find it. Anyway, let's see. Where's my calculator? Hopefully you could do this. What we're going to do is we're going to take this number that we got and we're now going to add it and subtract it onto the mean. So what we want was we want two scores. We want the mean to be in between, or the true mean to be in between this 116 plus our margin of error and 116.16 minus the margin of error, whatever that margin of error came out to be. Once we did that, those scores should come out to be 113. It should be 113.34, and it should be 118.89. So the true mean is somewhere in between here and here. This would be a sample mean. The sample mean was 116. The sample standard deviation was 10.27, where I think they'd still call this the population. It doesn't matter one way or another. It goes in here into the formula right here. And then what we're saying is that the true mean, we are 90% confident that the Apple stock, we'll write it out, the Apple stock will be between these two scores, $113 and $118. We could be 90% confident that for that year, from February to February, our Apple stock is going to be somewhere between these two scores. We're going to do another one, and it looks kind of crazy and convoluted a little bit at the beginning, but once you get the hang of it, it'll work out nice. If we look at number 38 here, 38 talks about the number of tornadoes in a month. All right, so let's pull information out of this and do it the same way we did the other one. What do we need? We need our sample size, the average, the standard deviation. We're going to need a z-score. We're going to find the margin of error. But we're also going to know what do we have to look up. So this one we're going to do at a 95% confidence level. So we want to be 95% confident that the information that we're saying is really the truth. So from this random sample, they're saying that n is 24. So we have a random sample. They took 24 readings of these tornadoes from January for the last 10 years through December 2016. And they said the mean number of tornadoes was about 100. Pretty amazing. So there's 100 tornadoes in those 10 years. Let's see. That's the mean per month, which is kind of insane. And they say is about 100. Assume the population standard deviation is 114. So this is very erratic. In other words, you got 100 per month, but the standard deviation is 114. That means some months have crazy amounts of hurricanes, maybe 200-300, tornadoes, and other months may not even have any. So it's very spread out, this data, because the standard deviation is so large. If we want to be 95% confident, we're going to put our 95% right in the middle here, 0.95. If that's 95%, then we call this alpha, the little Greek letter. What is our alpha number? We would take this 0.05, there's be 0.05 left over for these two spots, and if we divide that into 2, so this is 5% divided into 2, that means we have 2.5% here, and we have 2.5% here. That means in our table, we're going to look up 975. This is what we're going to look up. But again, there's a shortcut to this, but I want you to understand the process of what's going on. If I look up in my normal distribution table, the 975, I'm real close right in here. But if you notice, for 95%, they're going to give you 1.96. They give it to you. So in other words, they look it up for you. Where's my 95%? It's somewhere right in here. Oh, I don't know if you can see that. Which is 1.9. So 975 would be somewhere over here. 975, there it is. And if you look over it, it's 1.96. You could do that with your own chart and see that this is going to be, our z-score is going to be 1.96. Or that our alpha is going to be 0.25. So we have everything we need. Now we're going to find what we call the margin of error. And if you remember, the margin of error goes by this formula here. So we're going to get our z-score, which is 1.96. We're going to multiply it by our standard deviation, which was 114, and we're going to divide it by the sample size, the square root of the sample size, which is the square root of 24. Now, if you take that number that you get there, and you're going to add it and subtract it to the sample average. So this sample average plus the margin of error, and the sample average minus the margin of error, will tell us that our true mean is somewhere in between there and there, and we could be 95% confident that it will be between those two numbers. Let's pick up with part 2 to the video. I want to show you one more problem. We'll finish this one in part 2.